On the bench today we have a Fluke PM3394 oscilloscope. It has a couple of problems, but one of the problems is that the backlight for the Graticule has blown. The little incandescent lamp that illuminates the Graticule is completely unobtainium, and even if I could find one, the price of getting one here would be eye-watering. So what I'm going to do is upgrade the incandescent backlight to an LED backlight. I've done this before, but previously I've used white LEDs. This time I'm going to try using amber color LEDs to match the color that I want to see out of the Graticule. It should also reduce the amount of stray light that comes out of the illumination light guide, because the LED illumination will only produce the color that is displayed and not other colors that will not contribute to illumination of the Graticule. So the place where the lamp holder went, I've removed the lamp holder from this oscilloscope, is located at the top of the oscilloscope in an acrylic reflector that spreads the light from the lamp across the Graticule. And it's supplied through this wire here, which supplies a voltage in the range of 8 volts to 28 volts. And the reason it supplies 8 volts is that 8 volts was not enough to illuminate the lamp, the incandescent lamp that was there. So I need to replicate that with LEDs. So the last time I did this modification, I based it on strips of LEDs that I got from AliExpress. And those were the strips that were a constant voltage. They required 12 volts, and they had resistors on the strips that reduced the voltage down to that required by the LEDs. Now on the strip that I'm showing here, there are no resistors. These strips are based on groups of 10 LEDs, and each group divides those 10 LEDs into a set of 5 LEDs. And those 5 LEDs are connected in parallel. And to run these, you connect the power supply from there to there for the first set of 5 LEDs, which is set A, and then the group B ones you power from here down to there. So you end up with 2 pairs of power connections to each group of 10 LEDs. Now I didn't need 10 LEDs, so I actually cut the strip down and cut it down, so I ended up with 4 LEDs. The LEDs on this strip are white, and I didn't want white on the oscilloscope. I wanted amber. So I bought some LEDs from AliExpress. These give me strips of, I think, about 100 or so of a range of different colors, including amber. And so I took those and I swapped them out for the LEDs that are on the strip. They're a slightly different form factor. They have a narrower beam, which suits me, and of course the amber to match the color of the oscilloscope Graticule. Forward voltage that I see across the supply is actually 4 volts. Now the minimum voltage on the lamp and provided by the oscilloscope is 8 volts. 4 volts is not enough. To that I added a 5.6 volt Zener diode, so that effectively brings up the forward voltage before any light is emitted to 8 volts. And the current is limited by a resistor there, so at 28 volts I have a total of 30 milliamps through the LEDs. Each LED takes a maximum of 15 milliamps current. So let me give you a demonstration of this. I have my power supply set up to provide 8 volts at 30 milliamps. So if I turn that on, you will see that the LEDs are barely turned on, only just. Now I don't think that is going to be enough to illuminate the Graticule, at least in a way that will be visible. So that is my minimum. Now if I set this to 28 volts, which is the maximum, you see that the LEDs are a lot brighter, and in fact they're really too bright for the camera to properly display. So all I need to do is put this strip of LEDs into where the lamp was that illuminated the Graticule. So to do that, I've made this little aluminium piece here, to which I will stick on the 4 LEDs, 2 on each side, and then plug this into where the lamp went. And because this is aluminium, it will act a little bit like a heat sink. It's not going to be very efficient, but it'll provide at least a little bit of cooling. Not that I think there'd be much cooling required, because the LEDs don't dissipate very much power. Certainly not as much as the incandescent lamp that was located there. The strip of LEDs was folded over the aluminium to give a light source of 4 LEDs, 2 on each side. The light emitted from these LEDs wasn't bright enough. 4 LEDs was not bright enough to illuminate the Graticule. In addition, the Graticule wasn't evenly lit. There was 2 bands of amber down the sides and a darker band where there wasn't enough light getting down the middle. So the light pattern wasn't even and it wasn't bright enough. I decided to abandon this approach and try something new. And what I've come up with is mounting a total of 8 LEDs, including 2 pointing forward. These LEDs will not be based on a hacked constant current strip that I've got from AliExpress. I've decided to try soldering them directly together in a horseshoe shape. I've glued the LEDs onto the spacer, and I've also made a printed circuit board to hold the spacer and the LEDs, plus the 2 resistors that are needed to limit the current to each set of 4 LEDs that will be glued to this PCB. And this PCB I'm going to hold in place with a cable tie. Nice and simple. I've finished the LED Graticule. I've soldered the connecting wires from the top to the bottom, and also added on the current limiting resistors. So now I have a total of 8 LEDs, and this takes from 8 volts to 28 volts as supplied by the oscilloscope. So let's try them out and see what they look like. If I start at 8 volts, they will barely turn on. And there we go. So that is not enough to be seen on the Graticule. There's not enough light there by the time it gets through the light guide and then spread out across the Graticule to actually see it. Now let's turn the voltage up, and it very quickly saturates the camera. So at 28 volts, it is drawing 32 milliamps. So that's 15 milliamps for each LED, because that current, 32 milliamps, is spread across the 2 sets, the 2 groups of 4 LEDs. Okay, so it works on the bench. All 8 LEDs are illuminated. They're drawing the right current. Let's try them in the scope. I've just temporarily fitted the LED Graticule light source to the light guide, and it's got 8 volts on it at the moment. And when you look at the display, you cannot see the illumination. There's not enough there to illuminate the Graticule, which is good. Now, if I wind up the voltage, we'll see what this looks like. As you can see, we've got 14 volts on, and it's just starting to see it. The illumination is reasonably even across the display. I've got up to 22 volts. Illumination is quite easily seen. Take it all the way up to 28 volts. There we are. So the amount of flare is minimized compared to the white LEDs, and the coloring is exactly what I wanted. It's amber. The illumination is not quite even across the whole display, but close enough. It looks worse on the video than it does by eye. By eye, it looks quite even, but I'm quite happy with the results. Certainly a better solution than the 4 LEDs that I originally started off with. 8 LEDs is enough.